Alright guys, let's keep moving with this last section of chapter 6, which is 6.5, solving rational equations and problem solving. That is applications of solving this equation. Before looking at the main applications, right, that we're going to cover, so it would be a good idea to define what the cross multiplication property is, or right, which essentially we have two rational expressions that I'm going to highlight, right? A over B equals C over D, right? Proportion, right? This is called a proportion. A proportion is a statement that two ratios are the same, right? In order to solve this proportion, all we do is cross multiply B times C, which is what we have on the right hand side, and D times A, or A times D, which is what we have on the left hand side, right? Okay, there it is. All right. Okay, let's do an example of how to solve these proportions, right? So for letter A, right, solve the proportions. Now let's see. Cross multiply x times 3 and x plus 1 times 2. That'll be giving us 2 times x plus 1 equals x times 3, which is 3x. Okay. The next step to solve this equation, right, will be to distribute the 2. And notice something interesting about this last sentence, right? This statement right here, this equation no longer has denominators, right? So that's the main point of doing the cross multiplication property, because in this case, we no longer have denominators, right? So we're going to have 2x plus 2 equals 3x, okay? So one more step, subtract 2x to both sides of the equation, and we get x, 2 equals 3x minus 2x. Oh, that's x. So x equals 2, right? Let's look at another example, right? So 4 divided by 3, the quantity 3x minus 1 equals 2. However, keep in mind this number 2 has a invisible 1 in the denominator, right? So in this case, now the number 2 is going to look like a rational expression, like numerator and denominator. That way we may now do the cross multiplication property, right? So we multiply 1 times 4, which is 4, equals 2 times the quantity 3x minus 1. So let's distribute the 2, right? So 4 equals 6x minus 2. Okay, let's isolate the 6x first by adding 2 to both sides. That'll give us 6 on the left and 6x on the right hand side. And to get that solved, divide both sides by 6, okay, to get x equals 1. Okay, so that's final answer to solve this proportion. Now, on the next page, we are going to look at our first word problems, right, dealing with proportions, right, modeling with proportions. Okay, so we are going to look at situation. Let's look at a very simple case, right? So in this case, let's highlight the sentences that we're given. Number 1, 2 is to 13 as 11 is to x, right? 11 is to x. So we are going to write these proportions, right? This this as a proportion, right? Which is the equation of two ratios, right? So 2 is to 13 as 11 is to x, right? So 2 is to 13, right? Just the same as 11 is to x, right? So we have a proportion, which is the equality between two ratios. Let's solve it by cross multiplying, right? So 2x equals 13 times 11, right? 13 times 11, what do we get for that? Let's use a calculator. Here I get 143. And then dividing both sides by 2, we get x equals to 71.5. Okay, that's final answer for this proportion application. A very typical application in real life, right? So for example, if you want to wonder how much money are you going to make if you work a determined amount of hours. So for knowing one piece of information, for example, here we know that a person earns $143 in 11 hours. The question is, how much will that person earn in 17 hours? All right, let's see. Okay, 143 are earned in 11 hours. How much? That's the tricky part. How much? We don't know, right? Let's give that an x. How much, which is x, in 17 hours? Okay, so let's cross multiply this, right? Multiply 143 times 17 equals 11x. So 143, let's use a calculator, right? 143 times 17. Is that correct? Yes. 2431. Okay, let's see. Okay, so 2431 equals 11x. And then divide both sides by 11 to get x by itself. Okay, so cancel. X equals 221 in this case because we're talking about money, so let's put the dollar sign, right? So how do we know this problem makes sense? Well, a person is earning $143 working 11 hours, right? Well, the person is working more hours, he's working 17 hours, so we would expect to get a larger amount of money. In this case, $221 is larger than 143, right? Let's look at another fun application about proportions. Okay, let's see. So let's use a different color. Okay, so we have that a child which is 4 feet casts a shadow which is 5 feet long. The kid is next to a tree, right? We don't know the height of the tree, right? But they're telling us that the tree is casting a shadow that is 7 feet long. All right, let's draw a tree here. Okay, let's draw a tree. And let's add some effects here. Let's see, let's use a different green here. Let's make it a fun tree here, right? But we don't know the height of the tree, right? We don't know the height of the tree, right? So, but we know that the shadow being casted, right, is 7 feet, right? The height of the tree is unknown. We don't know what that is, right? And right next to it's a kid, right? And it's a kid, right? Whose height is 4 feet tall, right? And the kid is casting a shadow right? That is 5 feet long, all right? So this gives rise to a very typical geometry problem, right? A problem called similar triangle problem. How do we work with those? Notice this will give rise to the following triangle, the tree, right? The picture of the tree whose height is x and the length of the triangle is 7. And then we have a smaller triangle in which the height is 4 and the length is 5, right? So we are going to set the following proportion. Okay, let's look at how we get this proportion. So 4:5, right? That's the information highlighted here with purple, right? The information about the height of the kid, right? And the length of the shadow that he's casting, right? In this case, 4/5 equals x:7, right? In this case, the information about the tree, right? So in this case, x, because we don't know, is to 7. So we have this proportion right here. We have that proportion. Let's solve the proportion by cross multiplying 5 times x and 4 times 7. So 28, whoops, equals 5x. And the only one step we can do here to get x by itself, divide both sides by 5, cancel the 5s, get x equals 28/5, which approximating I get 4.2. Well, actually this goes nicely, 4.2 feet. All right. Wait a minute. It's not. Oh yeah, never mind. This is correct. Okay. 4.2 feet. Okay. 5 is to 5. Okay. 4 is to 5. Okay, let's look at a different application. Work and motion. Let's look at work problems first. Okay, so the situation arises when we have 2 or more people performing a task, right? Performing a job. So we're going to have information about the time it takes for a person to do one task. For example, let's look at the first example. It takes Mary to clean her apartment, right? Takes 3 hours. And then they're telling us that her roommate, right, takes 5 hours to clean the same apartment. Now the question is, how long will it take if they worked together? Okay, so Mary, let's fill in the blanks here. For Mary, that takes 3 hours, and for, well, I have Mike here, but in reality, this is the roommate. Okay, he takes 5 hours to do the work. Together, well, that's the question, right? If they help each other out, we don't know, right? So let's find out. So let's write an equation in terms of the names of the person, right? 1 divided by the time it takes person 1. 1 divided by the time it takes person 2. And 1 divided by the time it takes working together. Okay, so in other words, 1 over whatever takes Mary plus 1 over whatever time it takes the roommate, I'm gonna call it Mike, right, equals 1 over whatever time it takes together. All right, so let's put numbers to this. Let's put numbers. So this is going to be 1 over 5 plus 1 over, no, not 1 over 5, it's first 1, well, it's going to be the same anyway, but let's go in order. 1 over 3, 1 over 5, and 1 over whatever time takes together, which is 1 over x. So notice this equation has denominators, and in order to clean up those denominators, we need to find the LCD and multiply both sides by that quantity. In this case, the LCD will be 15x. Okay, so what are we going to do next? We're going to distribute the LCD over the two terms over the numerator of each term on the left hand side, and the LCD over the numerator of the rational expression on the right hand side of the equation. So this is going to be 1 times 15x divided by 3 plus 1 times 15x divided by 5 equals 1 times 15x divided by x. Okay, let's divide out common factors for each term. Notice 15 goes away with 13 and we get 5, right? 15 goes into 5 3 times. And on the right hand side, notice how the x's cancel. Okay, let's see. Let's keep going on that side. So we're gonna get 5x plus 3x equals 15. Combining like terms on the left hand side, we get 8x equals 15, and dividing both sides by 8, we get x equals we got x equals 1.88, 1.9 hours. Okay. So how do we know this makes sense, right? How do we know this makes sense? Well, of course, it takes Mary 3 hours. And it takes a roommate longer, 5 hours. If they help each other out, of course, it has to take way less amount of time than they would take each other, right? So there is a different approach using the table, the tabular approach. However, I'm not going to do this using the tabular approach. If you want to review how to do the tabular approach, I suggest you go back to the watch first video, the video that is linked on the same model, okay? So let's go over the next example, okay? Okay, so it takes a master carpenter 10 hours to build a set of cabinets, right? When he works with his apprentice, right, it takes 6 hours to do the same thing, right? Working together. Now the question is, how long does it take the apprentice working alone, right? Okay, let's fill in the blanks that we have below, right? So they're telling us that the master takes 10 hours. The apprentice, well, that's the question, right? How long does it take to the apprentice? In this case, we don't know. Let's just call it X. Together, they're telling us that together takes 6 hours. Right, the LCD, let's leave it blank for a second. Okay, let's set up this problem by writing 1 over whatever takes the master plus 1 over whatever takes the apprentice. Equals 1 over whatever time it takes if they worked together. Right? So let's write down the equation. That will be 1 over 10 plus 1 over the apprentice, which is x. We don't know how long does it take, right? Equals 1 over the time it takes together, 1 over 6. Again, this is a rational equation, right? We need to get rid of the denominators, clean up the denominators by multiplying by the LCD. And in this case, the LCD will be 30x. I know what you're thinking. You're thinking is the product of the 3 factors, right? 60x, and that's fine. That's still correct. However, there's a smaller number than 16 that divides both the number 10 and the number 6. In this case, the number 30, right? 30x. So I'm going to do the same thing I did on the previous problem. That is, distribute the 30x over the numerator of the first fraction. Distribute the 30x over the numerator of the second fraction. That is 1 times 3x, oh no, not 3x, 30x divided by 10 plus 1 times 30x divided by x equals 1 times 30x divided by 6. All right. Okay, let's divide out common factors on each term. 30 divided by 10, that's 3 and 1, leaving us with 3 times x, which is 3x. Next, for the second term, notice how the x's cancel, leaving us with 1 times 30, which is plus 30. And finally, 30 goes into 6 5 times, leaving us with 5x. All right. Okay, let's move the 3x to the right-hand side of the equation by subtracting 3x on both sides, leaving us with 30 equals 2x. And then divide both sides by 2 to get x equals 15. And in this case, we're talking about time, so and this time is mentioned in hours. All right, time in hours, and that's final answer, right? 15 hours, and it makes sense, right? Because 15 hours versus for an apprentice versus 10 hours for a master who already knows his stuff. Well, this makes sense. All right, let's look at the last applications to distance problems, right? Again, in this case, we're going to take this back, the same problem we solved when we went over when we covered chapter 4 on applications. So that was section 4.3 on applications of systems of equations, right, with two unknowns. That situation in which we have a boat traveling on a river, right? The situation in which the boat goes with the wind, right? With the current of the river, right? In that case, the current of the river is helping it's helping a boat go faster. That's what we call downstream, right? That's boat plus river, because in this case these two speeds are additive, right? So the boat is pushed by the current of the river, right? In this case, let's call that R plus whatever the speed of the river is, right? Which in this case is 3 miles per hour, right? The river flows at 3 miles per hour. For the other situation in which the boat goes against the wind, that is minus the rate of the river, right? So R minus 3, in this case, same speed of the current, right? All right, they're telling us that the boat can travel 8 miles upstream, right? That's distance. In the same amount of time, right, it can travel 12 miles downstream. Okay, notice this. In the same amount of time. Let me highlight that. In the same amount of time. So in this case, it doesn't matter going back or forth, right? It doesn't matter. That's just going to be whatever time is. I'm going to use T subscript U for upstream, and let me actually use against. T subscript A for against, and T subscript W for with the current. Okay, so then we're going to set a couple of expressions or mini equations here rather. T subscript A, and I'm going to divide the distance, right? The distance upstream over the rate upstream, right? That is, I'm going to divide 8 by R minus 3. Okay, let me do that. So that's 8 divided by R minus 3. All right. The same with the speed of the current. I'm going to divide the distance with the current by the rate of the current. Okay, with the current rather. So that's 12 divided by R plus 3. All right. Again, notice, let me go back and highlight what I highlighted here in blue. Okay, notice this is taken in the same amount of time, right? So this is telling us that whatever time against the current is the same time with the current, right? So if we use this idea here, then we can set these two expressions equal to each other, right? That is 8 divided by R minus 3 equals 12 divided by R plus 3. So now that's where we just solve the algebraic equation, right? So let's do the cross multiplication here, right? So we're gonna get 8R plus 3, keep in mind parentheses, equals 12R minus 3. If we distribute the 8 over R and plus 3, distribute the 12 over the R and the negative 13. No, not negative 13, that's negative 3 only, not negative 13. Okay. So 8R plus 24 equals 12R minus 36. So let's have the R's on the left-hand side by subtracting 8R. Cancel the 8R's. We get 24 on the left-hand side. And 12R minus 8R, that's 4R minus 36. Add both sides the number 36, the quantity 36, to get the R term by itself. That's a 16 and a 4R. All right. And finally, divide both sides by 4 to get R equals 15 miles per hour. And that's the speed of the boat. All right. Let's do another example, a very similar example, but instead of having a boat in the river, we have an airplane and the current of the wind. Again, we went over this in section 4.3 when we cover systems of equations, right? That is the rate of the plane minus, okay, the rate of the wind, right? The speed of the wind. That's when the airplane goes against the wind. Let's define what the rate of the wind is. In this case, well, okay, they're telling us that the speed of the wind is 30 miles per hour, right? So minus 30 against the wind and R plus 30 with the wind, in this case because the airplane plus the speed of the wind. All right. Okay, let's see. The airplane does 200 miles against the wind. All right. And the airplane does 300 miles with the wind. Okay, let's write it down where the distance is. Miles are units of distance, right? Okay, we don't know about time, but it's whatever time it is, right? If 5 hours, 6 hours, doesn't matter. The trip is done back and forth, right? So let's see. Takes the same amount of time, whether it goes one direction or the other direction. So let's just call this time against the wind and time with the wind. All right. Let's see. TA, which is the subscript E, to subscript A rather. Okay, we're going to divide the distance, which is 200, and the rate, which is R, in terms of R minus 30. TW, which denotes the time it takes with the wind. It's going to be 300 divided by R plus 30. All right. Again, this sentence in blue right here. Okay, let me take this here. This is telling us, right, that T against equals T with. Time against, time with. Time with. So that means we can set these two expressions equal to each other, right? So let's write that down. 200 divided by R minus 30 equals 300 divided by R plus 30. The next step for this to solve this equation is to cross multiply, right? So 200 times R plus 30 equals 300 times R minus 30. Okay, let's distribute this. Let's distribute it 200 over each term on the left hand side, giving us 200 R plus 6,000. That's when we can multiply the 100 by 30. On the right hand side, let's do the same. 300 R times negative 30. So that'll be 300 R minus 9,000. Okay, let's have all variable terms on the right hand side. Okay, by subtracting 200R on both sides. So this will be 6,000 equals 100R minus 9,000. And then let's isolate the variable term, the 100R, by adding 9,000 to both sides of the equation. All right. That'll give us, okay, let's cancel out the 9,000 on the right hand side, and we get 100R on the right hand side and 15,000 on the left hand side. Finally, we divide both sides by 100 to get R by itself. Divide, and this is R equals to 150 miles per hour. And it makes sense, right? How do we know this makes sense? Well, we're talking about a small airplane, right? Maybe a Cessna, not like a big commercial airplane, right? Like a 737 or an Airbus, right? One of those big commercial airplanes, so which go way faster than 150 miles per hour, right? And this is the end of the section, right? And so there was another topic that it's going to be also on the homework, but it's not here in the notes. So for this, you might want to use the back side of the page. So in this case, we are going to solve equations for variables, right? For example, solve 1 over A plus 1 over B equals 1 over C, right? And let's solve this equation for B. Okay, let's solve this equation for b. Notice in this equation, we're not solving for x unlike the previous examples, right? So in this case, they're asking us to solve for b. However, we cannot just add a, right, by 8 to add a to get b by itself, because in this case, b is only on the, it's in the denominator, right? So we cannot do that, okay? So let's see. We need to find a different alternative. We need to multiply both sides by the LCD. So the LCD between A, B, and C is itself A, B, C. So I'm going to multiply both sides by A, B, C. A, B, C. So let's distribute this to the numerator of each fraction on the left-hand side. Let me keep the same colors. 1 times, well, I'm just going to go ABC times 1 is ABC, right? Divide that by the quantity A plus ABC divided by the quantity B. And we do the same on the right-hand side, distribute to get ABC and divide that by C. Okay, at this point, let's divide out common factors. Let's do that on the first term. Cancel the A's. On the second term, let's cancel the B's. And on the third term, that is the term on the right-hand side, notice we can cancel out the C's. On the next step, this is what we're going to obtain. AB plus AC equals A. No, not AB. Okay, this AB here. On the left-hand side, let me correct the first term. We don't get AB. We get BC. All right. So let's see. We are interested in solving for B, that is from this term. On that term, we have both the letter we wanted to solve for, in this case, letter B. The thing we're going to do here is to subtract BC on both sides. And the reason we do that is to have all terms on the same side of the equation, right? On both terms that have the variable. And we do that to get the following. So AB minus BC. Notice here how B is a GCF. Let's factor out let's factor out the B. A minus C. That is going to give us A minus C. And finally, we divide both sides by A minus C. In this case, notice how we can cancel the A minus C. Sorry, I'm running out of voice here. Oh my God, I'm running out of voice. So we finally get B by itself, which was our ultimate goal, right? AC divided by A minus C. Okay. So that's one example. Let me do another example. Solve M equals A over R minus A. All right. And let's solve this equation for, let's solve for A. All right. Let's solve for A. So notice something interesting. Notice this A appears both on the numerator and the denominator of the right-hand side of the given equation, right? Before we can do anything, we're going to solve this by cross-multiplying. Keep in mind that M on the left-hand side has a 1 in the denominator, all right? So let's cross-multiply, right? To get 1 times A, which is going to be the quantity on the right-hand side, and N times R minus A, All right, so distributing the m, we're gonna get m times r and m times a on the left hand side. All right, and equals a. Now, just the same way we did it on the previous example, let's have all the terms that have the letter we want to solve for, in this case, the letter a. Okay, let's do this by adding an on both sides, right? This will cancel these two terms, leaving us with mr equals a plus an. Okay, notice how a is a common factor. Let's factor out the GCF, right? We did a lot of GCF, remember chapter 5, right? Factoring the GCF, and this is going to give us a times 1 plus m, and the left hand side remains the same. Finally, in order to get the a by itself, let's divide both sides by 1 plus n. Okay, and notice how this divide out, and we get a equals mr divided by 1 plus m. Okay, and that's final answer. All right, so this is the end of the section, guys. So let's by the way, this is the end of the chapter, right? So that's the end of the chapter, and of course all the homework is already on my MATLAB, right? And so one thing we need to figure out is how is the exam going to be. We'll think about it, and then of course, as usual, I'm going to be communicating with you. Okay, in the meantime, let's call it a day and see you on the next video.